Hey, everybody. So we're looking at 10.2 today, and it's dealing with graphing more quadratic functions. All right. Today's quadratic functions are all going to be in, again, standard form. All right. So basically, the theme of this lesson is we're going to learn a new semi-faster way of graphing a quadratic function. Okay. In the last lesson, if you guys remember, we used, excuse me, we use tables to graph those functions. Okay, today we're not going to be using tables. We're going to be using these three steps. Okay, so go ahead and get this title. Copy this graph. You can put this on your first graph. If you are not using the graph paper, remember you can draw your own graphs just really simply by doing x-axis, y-axis, and putting the little tick marks. Okay, so yeah, go ahead and copy this slide, and we'll get into it. Okay, so on this lesson, basically the way we're going to go about graphing, the first thing we're going to do is get our axis of symmetry onto our graph. Okay, the axis of symmetry is this line right here, and its purpose is that it divides our parabola, our graph, into, I guess, two equal halves. All right, and the nice thing about it, you'll see, is we can mirror points. If we get points on one side of our parabola, we can mirror them over the axis of symmetry to get those same points for free. Okay, the next thing we'll do after that is we'll get the vertex. Okay, the vertex, if you guys remember, is where our parabola comes to a point. All right, and the vertex, you guys can see, since it's a point, it has a coordinate x comma y. Okay, here's maybe the first thing to know. The x value of our vertex is the x value that we get when we find our axis of symmetry. Okay, so this first step is actually going to give us the first part of our vertex, and then we're going to use that to get our y value. Okay, and then the very last thing we'll do is we'll get our y-intercept. Here's the nice thing about it. The y-intercept, and by the way, what a y-intercept is where does our parabola cross the y-axis? You can see on this one, it would cross right there. Okay, that would be our y-intercept. And to find that, it's really simple. It's just our c value of our quadratic function. Okay, so that's three steps. Let's go ahead and first practice doing them, and then we'll graph them afterwards. Okay, so go ahead and get this first example here. We're going to do the three steps, and then I'll have you guys try one. Okay, so first things first is finding the axis of symmetry. Here's a little formula. X equals negative b over 2a. All right, where our b value is this one in the middle, our a value is the one in the front. All right, so this is the little formula we're going to use. Just for the sake of taking notes, let's copy the formula first. So x equals negative b over 2a. All right, and then from here we can plug in our values. So negative, our b value on this one we can see is a 12. All over 2 times our a value is a negative 2. All right, so it looks like we're getting negative 12 over negative 4, and then dividing that, it looks like we're going to get a nice clean positive 3. Okay, so usually this is kind of how I do the work here, and maybe I'll go one more step below it and say, okay, that means x equals positive 3. Okay, and sometimes I like to underline it. There's my axis of symmetry. All right, so what we then are able to do with that is when we go to find our vertex, and our vertex is x comma y, we know our x value. Okay, it is 3. Okay, what we need to figure out is our y value. Well, here's the good thing. We have an equation that's solved for y. Okay, if we plug in our x value into this equation and do a little bit of math, we can get what y equals. All right, so this is kind of where the majority of the work is on these problems, but let's go ahead and do it. So I'm going to say y equals negative 2 times x squared plus 12x minus 7. So I'm just leaving spots to plug in x, and we just figured out that x is 3. Okay, and then from here, this is where, maybe a calculator is nice to have. Just remember, we need to follow our order of operations. We need to do exponents first, and then multiplication, and then addition, and so on from there. So I'm going to do a few things in my head. So 3 squared is 9, and 9 times negative 2 gives me a negative 18. Over here, multiplying 12 times 3, we're getting a positive 36. And then this minus 7, just bringing it down. Okay, so basically last thing, I'm just going to do this math here. I'm going to use my calculator just because it's easier. So negative 18 plus 36 minus 7. Looks like we're getting a positive 11. Okay, so there is my y value, and there's my vertex. Okay, well, I guess maybe since we underline this one, let's underline this one. Okay, last thing, my y-intercept, where does my parabola cross the y-axis? It is my c value. All right, so the y-intercept is negative 7. Okay, and with these pieces of information, I can graph, my parabola. We're not going to do that just yet on this one because I wanted you to just be able to practice these steps here. So go ahead and take a minute and try one of these on your own using this new quadratic function. All right, do those 3 steps, and then we'll get into actually graphing. Okay, so my axis of symmetry, just a reminder, x equals negative b over 2 times a. Okay, so negative, my b value is a negative 2. Okay, don't forget that negative, that's part of the little formula here. Okay, on the bottom, 2 times a, my a value is that invisible 1. Okay, so double negative, I'm getting a positive 2 over 2. So it looks like x is going to equal 1. All right, and that means, my axis of symmetry, I guess it's worth, I didn't really specify, but that means my axis of symmetry will go through the x-axis at positive 1, but we'll see that when we get to the graphing. Okay, so moving on to my vertex, my x comma y, I have my x value of my vertex, it's a 1. I just need to figure out the y value, and that means plugging my x value into my function here. So y equals, instead of x, I'm going to leave a spot. So x squared minus 2 times x minus 3. All right, and again, we're plugging in our x value, which is a 1. Okay, so again, I'm going to do a few things. 1 squared is 1. Negative 2 times 1 is negative 2. And then bring down that minus 3. So doing all this math here, let's see. Negative 5 plus 1 is going to give me a negative 4. So there is my vertex. And you don't have to necessarily underline these, but I kind of like to do that, especially since it's color-coded. Last thing, my y-intercept is just this c value, this constant number by itself. So my y-intercept is negative 3. Okay, so those are the steps. Now we're just going to try those, but now we're actually going to graph these, put them onto a graph. So yeah, let's try out this one. Right. So yeah, take a minute, go ahead and get this, and we'll do the 3 steps. All right. So step number 1, we're going to find our axis of symmetry. Sometimes I like to shorten it to that. All right, and that means x equals negative b over 2a. All right, so let's start plugging this stuff in. So negative, our b value is a negative 6 over 2 times a, which is a positive 3. So double negative, we're getting a positive 6 over positive 6. So it looks like our our axis of symmetry goes through the x-axis at negative 1. Okay, and that's what this means. So let's go ahead and put that on our graph. Okay, just one thing to note. The axis of symmetry isn't technically part of your graph. It's just a tool to use to graph your parabola. All right, so when I do this, normally on my graph, I'll do it as a dotted line. Okay, so again, it's going to go through the x-axis at positive 1. So there's my axis of symmetry. Okay, and you'll see why we do this once we get to the very end. Okay, cool. So from here, let's go ahead and do the second step where we're going to find our vertex. Okay, the vertex, we already have a part of it. Our x value is 1. We need to figure out what our y value is, and that means plugging this thing into our function here. So y equals 3 times x squared minus 6 times x plus 2. All right, and my x value on this one is a 1. All right, so let's see, 1 squared is 1, 3 times 1 is 3, negative 6 times 1 is negative 6, plus 2. All right, remember, you can add these or subtract these numbers in any order. So I would do, maybe a 3 plus 2 is 5. 5 minus 6 gives me a negative 1. All right, so there is my vertex. That's its coordinate, 1 comma negative 1. So remember, when we plot points, start in the center, go on first the x-axis, left and right, and then the y-axis up and down. So we're going to positive 1 on the x, down to negative 1 on the y. Okay, and remember, your vertex will always land on top of your axis of symmetry. Okay, last thing is just getting our y-intercept. And this is, the easiest step here. Our y-intercept is this constant. Looks like it's a positive 2. Okay, so that means on my y-axis, my parabola is going to go through it at positive 2. So there's one of the points I can get. Okay, so here's the reason why we have our axis of symmetry. We can mirror points. Okay, if we have a point, a certain amount of units on one side of our axis of symmetry, we can mirror it to the other side. So I notice that this point here is 1 unit to the left, so I can mirror it 1 unit to the right. Okay, and on these problems, that's enough information for us to graph our parabola. So it looks like it's going up like this. Okay, cool. So that is kind of the idea there. I'm gonna have you guys try one of these, and then I think we're gonna do one more on our own after this. Okay, or one more together after this. Okay, so go ahead, try this practice problem. Do the 3 steps, plot all your information, and then we'll do a couple more. Okay, so first things first, axis of symmetry, x equals negative b over 2a. Okay, so negative, our b values of 4, 2 times a, which is then visible 1. So it looks like we're getting a negative 4 over 2, which is negative 2. Okay, so there is our axis of symmetry, x equals negative 2. Okay, so just remember, that means it's a line that goes through the x-axis at negative 2. Here's negative 2 on my x-axis, so there's my axis of symmetry. Okay, from here, doing the vertex. Okay, I have my x value. I need to figure out my y value, plug it into my function here. So y equals x squared, okay, plus 4x plus 8. By the way, you don't have to do the parenthesis thing like I do. I just kind of like it because it shows, okay, now I'm plugging in my x value. I think it's a little easier to understand when you're teaching it. Okay, so let's see, negative 2 squared is 4. 4 times negative 2 is negative 8 plus 8. All right, 8 plus 8 is 0, so it looks like y equals 4. All right, so there it is. Okay, last thing is our y-intercepts. So y-intercept is this c value, positive 8. Okay, cool. So let's go ahead and get this on our graph starting. I guess I went a little quick. I went on the vertex, or I skipped past it. So let's put that negative 2 comma positive 4. So we're going to negative 2 on the x up to positive 4 on the y. Okay, from here, now we can plot our y-intercept on the y-axis. It looks like our parabola is going to go through at positive 8. Okay, last thing is getting our other point. I can see that this point is 2 units to the right of our axis of symmetry, so I can mirror it 2 units to the left. Right. And there is our parabola. Okay, a couple things to point out. Notice how our quadratic here was positive and our parabola was going up, just like we learned in the last lesson. It's the same idea on the last problem. We had a positive number and it was going up. And which, by the way, since there was a 3 here, this was more narrow than your typical problem here. Okay. And one thing to know though, on the last lesson, we had it to where if there was a number being added or subtracted, that's how many units our parabola would be going up and down. That's not the case when you have a b value. Okay, so this plus 2 didn't tell me this thing was going to be shifted up 2 units. All right, same thing with this. This plus 8, this thing wasn't shifted up 8 units. So be careful with that. It only works really when you're parabola lands on the y-axis. Okay. All right. So let's do another one of these together. Let's take a look at this example where we have a negative quadratic here. Copy this. Okay. So nothing new here. Let's go ahead and just do the axis of symmetry. All right. So x equals negative b over 2a. Okay, so we have our b value is a negative 8 over 2 times a, which is a negative 2. Double negative gives me a positive 8 over negative 4. So it looks like our axis of symmetry is going through the x-axis at negative 2. All right, so let's go ahead and get that on our graph. Here's the negative 2 on the x-axis. There is our axis of symmetry. Okay, by the way, on any of these problems, your axis of symmetry, it will always be a vertical line. All right, moving on to the next one, our vertex. Okay, we know our x value, it's a negative 2. We got to figure out our y value. Let's plug that into our function here. So y equals negative 2 times x squared minus 8 times x minus 7, and our x value is a negative 2. Okay, so let's see what happens. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is a positive 16 minus 7. All right, so let's see. 16 minus 8 is 8. 8 minus 7 gives me 1. All right. So, just be careful. If you're going to mess up on any of these problems, it's probably going to be in this step. So just, take your time on this. Make sure you're not messing up. Okay, so yeah, let's plot that real quick. Vertex is at negative 2 on the x, positive 1 on the y. Okay, last thing is our y-intercepts, which we can easily see is a negative 7. Okay, so it's crossing the y-axis down here at negative 7. Okay, last thing is we can mirror this point. If it's 2 units to the right, we can mirror it 2 units to the left. And we have our parabola. Right, and I said before, your parabola should go all the way across the graph. So try to do that. I don't know if I did that on the other problems. Yeah, kind of. I went a little short on this one. Try to draw it all the way across. Cool. So yeah, that is graphing using basically the most common method of graphing a quadratic function. It's only 3 steps. It's really not too shabby. Really, as long as you can get going with this axis of symmetry and remembering this little formula, everything else kind of falls into place sort of naturally. Okay, cool. So that's where I'm going to leave this one, and I'll see you guys in class. Bye.